Assalamualaikum. Today we will conduct an experiment that called Orifice Coefficient Measurement. So the objective of this experiment is to determine the coefficient of velocity and the discharge of two different diameters of orifice.
So the apparatus that we use in this experiment is reservoir, motor switch, water supply valve, prop board with 6 props, orifice with 8 mm diameter, orifice with 4 mm diameter, and water tank.
So next, the procedure is first we switch on the switch, then open the valve to fill up the reservoir until 55 cm for the trial first. Then allow the water through the orifice. We use orifice of diameter 8 mm.
And for the second step, we have to adjust the prop tip to be just in contact with the jet. For the next step is record the tip of the prop profile on the graph paper.
Alright, so the step 4 is we must record the flow using stopwatch and this area is indicated. So we must fill until 250 ml. Alright, so the time taken is 2.5 milliseconds. Okay, the next step is decrease the volume of water in the reservoir into 28 cm. Okay, after that, we repeat the same step to collect the data.
Change the orifice with diameter 4 mm. After the change of orifice, we repeat the same step and record the data.
My name is Ratna and I will explain about the result of this experiment. So here's the data that been collected from the experiment. So for table in part A is to find the coefficient of velocity, while for part B is to find the coefficient of discharge. The first graph is to find the coefficient of the velocity. So based on the graph, the coefficient of velocity for the diameter of the orifice 0.008 meter is 0.74. Next, based on the graph, the coefficient of velocity for the diameter of the orifice 0.004 meter is 0.75. The last graph is to find the coefficient of the discharge for both diameter. So this is the formula. The coefficient of discharge for diameter 0.008 is 0.65, while the coefficient of discharge for diameter 0.004 is 0.63.
My name is Nurul Faraiza and I will explain about discussion. The coefficient of discharge of an ideal pipe is between 0.60 until 0.80. This is because the theoretical and actual flow rates values concise. However, the existence of such a pipe is hypothetical and energy of frictional losses during the flow of fluid can be minimized but not eliminated. For this experiment, the coefficient of discharge for diameter 0.008 meter is 0.65 and for diameter 0.004 meter is 0.63. It is in the ideal range for coefficient of discharge. Depending upon the viscosity of the fluid and its Reynolds number, the different types of orifice plate can be used. This includes segmental, eccentric, conical, and quadrant orifice plates.
So my name is Ahmad Aiman and I will explain about the conclusion for this experiment. So according to the result of this experiment, the flow rate affect the coefficient of discharge, and the higher the discharge coefficient will be the lower flow rate. It was discovered that the flow rate hardly affected the coefficient of discharge if the pressure tapping were placed in the different location. We also can conclude that the increase in diameter of orifice will increase the volume of fluid discharged as a pressure acting on it increase.